All right, let's just jump right in. Back in 2020, an AI pulled off something absolutely monumental. A breakthrough so huge it's already changing medicine and, honestly, our future. And no, this isn't some sci-fi movie plot. This actually happened. This is the story of how a machine cracked a problem that had our best and brightest scientists stumped for half a century. I mean, really think about that for a second. A single problem that defined entire careers in science. A challenge so ridiculously complex, some people thought it was literally impossible. And then, boom, it was just solved overnight. That's what we're going to unpack today. The story of how it happened, and maybe even more importantly, what it means for what's coming next. So, to really get why this was such a big deal, you first have to understand the mystery itself. We're talking about one of the grand challenges in all of biology, a puzzle that just tortured scientists for decades. It's called the protein folding problem. Okay, so proteins. Your whole body is basically built out of them. Think of them as these tiny microscopic workers that do pretty much everything, fighting off diseases, digesting your lunch, carrying oxygen through your blood. But here's the thing. A protein starts out as just this long, kind of boring chain of amino acids. But then it does something that's basically magic. It folds itself into a super complex 3D shape. And that shape, well, that's the whole ballgame. As you see here, a protein's shape determines its function. If it folds perfectly, it works like a specific key for a specific lock. But if it misfolds, even just a little bit, that can lead to some really devastating diseases like Alzheimer's. So for decades, the holy grail was obvious. If we could just predict the shape from the sequence, man, we could revolutionize medicine. So you might be asking, why was this so hard? Well, this quote on the slide, it just says it all. The number of ways a single, typical protein could fold is bigger than the number of atoms in the entire universe. I mean, just let that sink in. Trying to guess the right one by brute force would take, longer than the age of time itself. It was, for all intents and purposes, an impossible problem. And this timeline, wow, it really puts that struggle into perspective. Just look at this. It all starts in the 70s when scientists first identified it as a massive challenge. Then in '94, they start a competition called CASP, just to track any progress. But progress was, well, it was painfully slow. By 2018, after decades of work, the best models were only hitting about 40% accuracy. The consensus was a real solution was still decades away, if we could ever get there at all. And then 2020 happened. Just like the timeline shows, everything changed. DeepMind, an AI company, showed up to the competition with a system they called AlphaFold. And it didn't just nudge the needle forward, it completely blew the doors off the hinges. The reaction from the scientific community was just pure disbelief. I love this quote because it captures it perfectly. The results were so good, so insanely accurate, that a lot of top researchers just flat out assumed it was a mistake. They literally couldn't process that it was real. Now, this chart right here shows you the sheer scale of that leap. I mean, just look at it. For years and years, the best models, that first bar, were stuck around 40% accuracy. Then AlphaFold comes along and just casually drops to 92%. 92. That's a score so high, it's basically on par with doing the expensive, time-consuming experiments in a real lab. It didn't just beat the old methods. It made them obsolete. It solved the problem. Okay, so that's a really cool science story, right? But why does it matter to you? To me? Because solving this problem was never the end goal. It was the starting pistol for a revolution that's happening right now in medicine and, well, pretty much everywhere else. Ever since that breakthrough, AlphaFold has been busy. It has predicted the structure of virtually every known protein. We're talking over 200 million of them. That's the kind of work that would have taken scientists centuries to do in a lab. And the best part? DeepMind just gave it all away, for free, to everyone. And here's how that changes everything on the ground. Take drug discovery. Look at the left side here. Before AlphaFold, a new drug would take, 10 to 15 years and billions of dollars to develop? And a huge piece of that time was just spent trying to figure out the 3D shape of one single protein. Now look at the right. With AlphaFold, scientists can get that same understanding in hours. The whole timeline is getting compressed from over a decade down to just a couple of years. It's insane. And the impact just keeps spreading. We're getting brand new insights into diseases like Alzheimer's, Parkinson's, and cancer that have baffled us for decades. It's not just about fixing things either. Engineers are now designing totally new proteins that have never existed in nature. Things like enzymes that can eat plastic or microbes that can make crops healthier. We're just scratching the surface of what's possible. But here's what I think is the biggest takeaway from all of this. The story of AlphaFold, it isn't really just about proteins. It's a blueprint. It's a new pattern for how scientific progress itself happens. And we're seeing this same pattern start to repeat itself in almost every field you can imagine.
And this is the pattern right here. Step 1, a problem that we all thought was intractable, maybe even impossible, suddenly becomes solvable. Step 2, progress just goes exponential. Decades of slow grinding work get crunched down into years or even months. Step 3, and this is huge, these incredible new tools and discoveries are often made open and accessible to the whole world. And finally, Step 4, each breakthrough doesn't just solve one problem and unlocks the next one, creating this amazing compounding effect where discovery just gets faster and faster.
So, if this pattern holds, the question is obvious, right? What other impossible problems are about to get solved? Well, let's take a look at what's already on the chopping block. I mean, look at this list. These are the grand challenges that have held us back for decades, and they're all starting to yield to this new approach. We're talking about more accurate climate modeling, controlling the superhot plasma needed for fusion energy, discovering brand new materials for batteries and superconductors, even helping prove mathematical theorems that have stumped geniuses for generations. It's happening across the board. And here's the part that really bends my mind. We are at the absolute beginning of this curve. The incredible AI systems that did all this, they're going to look primitive, like a pocket calculator, compared to what's coming in just the next few years. The pace isn't just fast, it's accelerating. We are genuinely living through this unique moment in history, a time when the very definition of impossible is being redrawn, not over lifetimes, but in months. It leaves you with one hell of a thought, right? With this new way of making progress, what impossible problem do you think is going to be solved next?